In this movie, we are going to talk about the STK AzEl mask tool. First, we'll create a new scenario with the default time period. Click Create a Scenario. Give the scenario a meaningful name such as STK Sensor AzEl Masking. Keep the default start time. Change the stop time to +1 second. And then click OK. When your scenario first opens, click the Save icon. And when the Save As window appears, click Save. I don't require the timeline view for right now. I'm going to close it. You don't need to do this if you don't like. I'm going to maximize my 3D graphic window because most of my scenario is going to be visualized in 3D. First, I'm going to disable the terrain server for STK, so I'm going to right click on Sensor AzEl Masking in the object browser, select Properties, browse to the basic terrain page, and in the terrain server field, disable Use Terrain Server for Analysis, and then click OK. In the 3D graphic window, go to the toolbar and click the next to last icon called Globe Manager. Go down to Globe Manager and on the toolbar, click the first available icon called Add Terrain Imagery. In the Globe Manager Open Terrain and Imagery Data window, go up to the top where it says Path, go all the way over to the right, and click the ellipsis button. In the Browse For folder, expand Computer, your C drive, Program Files, AGI, STK11, Help, STK Training, and then select Imagery and click OK. Select the St. Helens Training.pdtt terrain file and click Open. Do you want to use this terrain for analysis? Select Yes. In Globe Manager, right-click on St. Helens Training PDTT and select Zoom to. If you use your mouse, you can turn the terrain on its side and you can see the terrain file sitting on the WGS84 ellipsoid, and as you zoom in you can see more detail. Save your scenario. Next, we will ensure a ground site considers terrain. Return to the Insert STK Objects tool, select Place as your object, from City Database as your method, and click Insert. In the name field, type in Morton, M-O-R-T-O-N. In the lower left-hand corner of the Search Standard Object Data window, click Search. In the Results field, select Morton, Washington. And in the lower right-hand corner, Click Insert. Then you can close the Search Standard Object Data window. We're going to ensure Morton considers terrain height for its altitude. Right-click on Morton in the Object Browser and select Properties. Ensure that Use Terrain Data is enabled, and then browse to the Height Above Ground field and change that value to 20 ft for 20 feet. We are simulating the height of a 20-foot tall building. And then click Apply. Browse to the basic AzEl mask page. We are going to define an azimuth elevation mask and use it for an access constraint. Change Use to Terrain Data and enable Use Mask for Access Constraint. And then click OK. Save your scenario. Next, model a sensor on Morton. In the Insert STK Objects tool, select Sensor as an attached object, insert default as the method, and click Insert. In the Select Object window, select Morton, and then click OK. Return to the Object Browser. We're going to ensure that our sensor sees the terrain, but first we will rename the sensor. We'll call it Sat Tracker. So right-click on the sensor, select Rename, and call it Sat Tracker. Right-click on Sat Tracker and open its properties. Change the sensor type to a complex conic. Change the half angle's outer value to 180 degrees and click Apply. Browse to the Constraints Basic page. Enable AzEl Mask and click Apply. You have now taken the AzEl mask that you created in the Place object named Morton, and you are using it for your sensor. Next, we want to display terrain obscuration. Browse to the 2D Graphics projection page. In Field of View, enable Use Constraints and select AzEl Mask. Click Apply. Browse to the 3D Graphics projection page. In the Space Projection field, change the value to 50 kilometers. This will just show you the sensor up to an altitude of 50 kilometers in your 3D graphic window. Click OK. And when you return to your 3D graphic window, use your right mouse button or your scroll wheel and zoom out into space, and you can see your sensor. You can see it up to an altitude of 50 kilometers, and you can see the terrain blocking the sensor's field of view due to the fact that your sensor is very jagged looking, otherwise it would be conical. Next, we are going to model an obscuring object. Return to the Insert STK Objects tool, select Facility as your object, insert Default as your method, and click Insert. Rename your facility object Building. Building. Zoom back down to Morton. And if you look on my screen, you can see across the street from Morton, there's a large white roofed building. This is the building we are going to use as our obscuring site. So the first thing we're going to do is we're going to use the 3D object editing tool to place the building in the middle of the white structure across the street from Morton. Go up to the toolbar area in STK and locate the 3D object editing tool. Open the pull down menu if you do not see your facility called building in here, and select your facility building. It's very important that facility building is what you're editing. Go over to the right, click on the Object Edit Start Accept button. Bring your cursor down to that white building across the street from Morton. Put it approximately in the middle as best as you can. Hold down your Shift key and left click. Then you can return to the 3D Object Editing tool and once again click the Object Edit Start Accept button and accept your change. And as you can see, across the street from Morton is a large building. If you look closely, you can see that the sensor object, its field of view, passes right through the facility object. We're going to create a sensor AzEl mask which will show us how that building across the street is affecting the field of view of your sensor. Right-click on Sat Tracker in the object browser, drop down to Sensor, and then select AzEl Mask. In the AzEl Mask for Sat Tracker tool, in Obscuring Objects, select the building. Drop down to the data field, and where you see File, go all the way over to the right, click the ellipsis button. Ensure your file is going to be stored in your STK Sensor AzEl Masking folder. Drop down to File Name, and we'll simply call our file My Body Mask. And then click Save. Double check your file that it says My Body Mask. Next, we are going to change the window dimension to a value of 500. Drop down to the bottom of the AzEl Mask tool and click Apply. Ensure that you are not blocking the window, the Sat Tracker window on the left, the view window, and then come back over to the AzEl Mask tool and click Compute. Close the AzEl Mask tool and close the Mask View window and save. We're going to ensure the sensor uses the body mask file during access calculations. Return to the object browser, right-click on Sat Tracker, and open its properties. Select the Basic Sensor AzEl Mask page. Change Use to Mask File. Go all the way to the right on the mask file and click the ellipsis button. In the Select File window, select mybodymask.bmsk and click Open. Enable Use Mask for Access Constraint and click Apply. Next, we will display the body mask file obscuration. Go to the 2D Graphics projection page. In Field of View, we want to ensure that we keep the original AzEl mask highlighted. That's showing us our terrain masking. So I'm going to scroll down in the list and find the sensor AzEl mask. Hold down your Control key on your keyboard and then click on Sensor AzEl Mask. If you scroll back up, you want to make sure AzEl Mask and Sensor AzEl Mask are both selected. Click OK to accept your changes and close the Properties window. And now if you look at your Sensors field of view, you can see that the facility object across the street from the sensor is now blocking the sensor's field of view. So what you've done is you've used terrain and, in this case, a facility object model to block the field of view of your sensor. And as I scroll out in space, I can see that blockage on the edge of my sensor. Save your scenario,